Oh, I think we are ready. Ladies and gentlemen, our telescope and astrophysics club, the Santa Barbara Astronomical Unit, well into our sixth year of this weekly Zoom program on YouTube. You're about to see it's called the SBAU Astro Hour. And this will be episode 273 for May the 18th through the 24th, 2026. And my name's Ronnie here on your Monday morning quarterback. Actually, I'm a host. Notably because during the last part of my Santa Barbara radio career, everybody, these knowledgeable gents around me on the Zoom screen were my favorite on-air guests twice a month. We're simply continuing what we used to do in the studio or on the phone, this time without commercials, since we all share and love this fun science. We'd assume you do too, cosmology. SBA is all about it, SBAU. We're based in the beautiful Santa Barbara Museum of Natural History, where we have our general meetings with world-class science speakers on the first Fridays of the month. Meet outside in the dark a week later on the second Saturday star parties that are pretty well attended. Even help scan the surface of the sun on Sundays using the museum's Palmer Observatory scope. Learn all about this and more at sbau.org, all right? Stand by to meet the rest of the herd, the board, important people of SBAU who are going to be talking this week about these topics. Some holdovers we didn't get to last week. Doggone solar activity making orbiting space junk crash into the Earth's surface faster, hopefully giving us Earthlings a meteor shower or two. Another second take topic, how massive black holes grow. Maybe. That might be a surprise. The two LIGO detectors, how gravitational waves happen. And we do get to observe them these days. NASA's Psyche mission passing Mars gets a little bit of a boost. It's on its way to Jupiter, I think, isn't it? We got craters. Where?
It's going to Psyche.
Oh, it's going to Psyche, the asteroid. I see, that's right. Craters, not just on the moon or Mercury, but somehow out of the constellations. One's near Corvus the Crow and Virgo. A never-before-seen galaxy has been spotted orbiting the Milky Way. How in the world did we miss that? And get this, our club hasn't had a field trip in years. Kind of wish this one would be possible. It's a Saturday story in the New York Times about railroad train theme rides, 5 of them. And one of them was a nighttime trip from Ely, Nevada, eastern Nevada, out into the desert at night. It's a full train of people wanting to see enough stars you wouldn't believe the night sky. That would be great. Let's meet the gang, our Astro crew. First, the man behind the talking points, our SBAU president, who becomes Professor Jerry Wilson. Monday mornings, Jerry.
Good morning, everybody. Good morning to my sister Joyce and my grandkids, Calvin and Riley. And we've got construction going on in the background, so I'll mute myself a lot if it gets loud. And
Can't hear you.
I apologize for the
Yeah, we can't hear you.
for the look.
You stole that one from me.
Yeah.
Yeah, can you tell the First Lady Pat Forgy to put that hammer down for an hour?
Yeah. It's the chainsaw.
I found that a lot of that stuff, those big marboard trucks go by my house and none of it gets in here. I don't know why that is. And yeah, the TV will. Nevertheless, ladies, I hope you're watching. Our club's outreach coordinator to my left on screen is one of the best in America, Chuck McPartland.
In the universe.
In the universe. He
in the visible universe.
Yeah.
And his wife's not Pat Chop Liver either. Her name is Pat. Merchandise manager all these years and now taken over as an outstanding treasurer. She even popped her head in earlier before we went on. Let's go to Mr. Tom Whittemore,
Morning.
former Westmont professor of science, who now watches birds and bakes bread for us. And he is married to Maureen.
Yeah, planting lots of things now, Ronnie.
Lots of what?
I'm planting lots of things out back.
Are you really? You got room in your house to make a little garden?
Oh, yeah. We recently had a brand new garden fence put in, and it expanded the garden area, and it makes it really safe to walk around in, and I have garden boxes and stuff, and I've been putting in things every day. you know,
Well,
that
what's the fun of that?
What's that?
What's the fun of that? Makes it safe to walk around.
Well, a few weeks ago, I actually tripped over something before the fence was built, and it wasn't fun.
No.
I'll bet you as a birder, you have an incredible hummingbird feeder hanging
Yeah, I
out.
wish I could show you behind me. All you see is the grapefruit tree, but if I were to move my computer just a little bit over, you'd see these beautiful hooded orioles eating grape jelly out of our feeder.
Well, I know we're all going to get bags of that because you're going to have so much it'll be on the ground, and so we're all going to free grapefruits. Here's Tim Crawford, resident lens expert.
Math dummy.
Yep, superstar speaker for our December in-house members only. He'll open for the gentleman above him on the screen, talking about a moon around an asteroid. Tim, how's your wife Karen?
She's doing good, boy. The garden is getting bigger over here too.
That's neat. That's good.
So when
Yes,
you do your speech, when you do your speech in December, you do plan to show up at the museum, right?
Oh
Or
well, I might do the speech. You know,
on Zoom.
well, I might abandon you.
You'll be have a big black and white talking head like we had Bob Berman way back east. Okay, let's do the sillies. Did I get everybody and their wives? God love you. Let's do our silly cartoons of the week.
I'll be right back.
No, we're not. Wait a minute. It's time to do the humor.
Yeah, thanks for the warning. Thanks for the warning, Tim.
Yeah, you got to go to the bathroom. You got to go. All right, you're gonna have to increase the. There you go. It's gonna be funny. After a hangover, and you wake up, and Mr. President, you want to tell us what's happening in this for crying out loud?
Oh, this guy's waking up in someone else's bed, and he says, "Remember leaving the bar last night and saying my car looked like a spaceship?"
That's really good.
From the Cantina Band in Star Wars. That was one of my favorite scenes. You don't see the Cantina Band, all those aliens. Okay, you said 9. This is one for me because I like hats. I never thought of this one. Just go upside down and put my head on the grass, and doggone,
You got to have a hat on.
yeah, I gotta have one of the biggest hats, actual
Exact
size.
replica of the Earth hat.
I love this one. I'm gonna keep this somewhere. Okay, there's a total of 9 you sent us.
Oh, was it?
Chuck, you want to get us through this one?
Okay, astronaut with his helmet off, standing there talking to an astronomer who's looking through a telescope. And the astronomer says, "Good news, I see your keys next to the flag."
Very good.
That's where you left him. All right, Mr. Whittemore, what happened here?
It looks like the guy's, doing his nightly prayers, okay? And
Okay.
talking to God, looks like. So he says,
Yeah.
and something comes crashing through the ceiling. So that's a no, I take it.
Okay, God does answer prayers. Mr. President, again, which constellation?
This is a game you could play if your waitress is taking too long to get to your table. Which constellation is the best visual match for midair salt on fries? So I think Cassiopeia here, since it's a W, that one's the one for
That's
me.
pretty good.
Leo.
You like Leo better, huh?
Yeah, well,
Depends how you shake it.
yeah, it
That's
depends.
it.
It's all
I like a lot of
it's all in
salt
the
on my
wrist.
fries.
That's pretty good.
Okay, we have a couple of aliens, I guess, sitting off Earth and checking it out, and one says to the other, you don't want to go down there, Charlie. It's only a 1-star planet. Besides, that's where the universe keeps all the lunatics.
Very good.
Yep. Okay, who wants to take this one? Chuck?
Okay, to spoof everyone on Earth, the Mars crew smuggled aboard a hen and let it take the first steps on the red planet.
So why did the chicken cross the Martian landscape?
Right.
Okay. Bizarro, my God, who, Jerry?
Okay, this is at a public market, something where this guy sets up and he draws real quick caricatures of people. And he's doing a portrait of a stick figure guy, and the guy's trying to pay for it. He says, "No, really, just take it. I wouldn't feel right charging."
Now, isn't this the one that all these different little things are on?
Bizarro
Oh, there's a
does that.
K2.
There's a pie over there.
There's the upside down bird on the guy's t-shirt,
Where's that?
Okay.
kind of right under the text bubble.
Oh, yeah, there it is.
Oh, and then there's a K2 on the wall.
Yeah.
Bizarro. Where do you
Yeah,
find a
K2. And then
Bizarro?
there's a firecracker down here and an eyeball.
Yeah. And the little spacecraft, the little alien is just under the tree in the upper right corner.
Oh, yeah, right
Oh,
there with
God,
the
man,
alien in it.
I didn't see any of these.
But the first one you mentioned, the upside down bird, is that this?
Yeah.
Yeah.
Gary.
Oh, yeah, it is. BIRD, upside down. Yeah.
I like these. Where did these show up at?
They're in the LA Times comics.
Oh,
You can also tune into them on Facebook or just on the internet.
they're really cool. I like them.
Yeah.
The guitar player is always in the upper left there. All right.
Here's another one.
Tim Crawford, what's going on here? You want to tell
Okay,
us?
let me see. I didn't. This one, oh, if you type parenthesis colon 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 asterisk, it makes a happy face.
Yeah, see, it looks just like him.
Yeah.
Type keyboard.
And there's the alien there.
And there's the pie.
K2.
K2
K2.
eyeball right up to the left there on the table.
Is there a word for those? They're not emojis, are they?
No.
Oh, yeah, there's the eyeball here.
Yeah.
And there's the
Both.
firecracker
Sort of do-it-yourself emojis.
Where's the firecracker? Oh, yeah, there it is.
right
Okay.
there.
And the piece of pie is on the
Oh,
bottom
yep, right there.
left, kind of. Yeah.
Where I don't see the pie.
Six
Oh,
eyeballs.
I see it right there.
Yeah.
Pretty sneaky putting it right up
And
front.
they put a bird. I don't see the bird.
Where's the bird?
Unless
What are you looking for a bird for? I don't understand.
You don't always get all of them in each one. So I think the bird got left out of this one.
yeah.
We're not seeing what they're typing. We're just hearing about it.
Yeah. And there's a finger here.
Oh God. That was in lieu of the bird.
Yeah, maybe that is the bird. Yeah.
Yeah, the bird.
Oh, yeah, that's right. It would probably be it.
Okay, that's me. These are really neat.
Uh-huh. I don't know how all of a sudden AI or something is sending these my way from Bizarro.
They're neat. I really like these, Jerry.
Okay.
You can bet there's a cookie on your system.
Yeah.
Any of
There's
you
so
ever
many
put
cookies.
you ever put a colon with a closed parentheses to make a sideways smiley face?
Or
I've
a
seen it.
brownie with the other parentheses.
Yeah,
Yeah.
but I don't do it.
Sure, you're right. Okay, let's get serious. Go to the night sky, as we like to start these programs. Number 273, the Astro.
Hey, Jerry, you're back in narrow field.
Yes, but every now and then I flip out there.
Oh,
See,
there it goes. Don't move.
There's nothing wrong with that. I like that. Looks like you're inside the Millennium Falcon.
He is.
yeah,
In his way, he is. He's Han Solo with the beard.
Wow.
Okay. Ooh. Held over from last week.
From yesterday.
Yeah.
almost.
Yeah.
Okay.
This is a picture of some flares about a week ago, I believe.
Okay.
It's a multiple exposure thing. You can see the ring around there. So this is a composite picture to get the disk and the corona.
Wow.
But it's the intro to the fact that we have a very active sun, and a group of people at in India studied solar cycles over 36 years.
And it's really washed out. So a lot of the graphs disappeared here.
Okay. Yeah, okay. Let me just try and clean the screen up so I can get to the other.
There's a late score just in. AI 12, Astro Hour 3 going into extra innings.
This has nothing to do with AI.
No.
Oh, wow.
That's
Okay.
a lot.
Yeah. Yeah, one
So-
completely
Well,
disappeared.
all AI these
So
days.
this is 36 years is a 3 solar cycles, and here we are started with the 25th solar cycle, or the 4th solar cycle for this chart. So this is the activity, and this is the loss in altitude. This is kilometers, and this is the original minus the radius loss due to the activity. And you can see that during this region, the satellite experience from this activity, the satellite lost this altitude.
Wow.
So this is for low Earth orbit only, this, and where they're near the Earth's atmosphere. And the Earth's atmosphere swells and it creates drag on the things. And this is what takes out approximately up to 100 or more Starlink low Earth orbit satellites every year, and they have to keep pumping them back in. He's trying to get to 1 million, but he's fighting the current.
Yeah.
Because the sun is turning them off as fast as he does. So this one here at about 700 would be down to about 550. So it's lost 150 kilometers in altitude. And that's where it starts re-entering the Earth's atmosphere.
And you can just flip that second graph, which is the cumulative number of sunspots, and it almost mirrors the decay
loss
graph up top.
Yeah.
Oh, pretty soon we're going to be having second Saturday Starlink parties.
Well, I think it's like every 16 hours he deorbits one.
Wow.
Deorbits?
Deorbits.
Deorbits, yeah. Takes them out of orbit.
Yeah.
Burns them up in the atmosphere.
On purpose? Or the
Yeah.
sun?
Yeah.
Really?
No, Elon does that. They have limited lifespans.
So it's what Jerry's talking about. The sun is doing it.
No, Elon does it.
He does it?
Yes.
Does it fire a retro rocket? And
Yes.
I'll be damned. Each one of them is like a little computer,
Yeah.
probably worth thousands, and just like that, we dispose of them.
Yeah,
Yep.
they're expensive.
So Elon equals sun.
Yeah. I think in his mind, yes.
Yeah.
Yeah.
I've got a different equation for that boy.
Yeah.
Now this is down here, this is EUV flux, which is extreme ultraviolet. So this is very short wavelength. This is the thing that interacts with the atmosphere to swell it.
Right.
So
So this is the field we studied at the Lockheed Research Labs, Jerry.
Oh, you did? Okay.
Yeah. With X-ray telescope, real soft X-rays.
Okay. So it's not the visible light or the infrared that is doing it. It's this extreme UV that interacts with our atmosphere that causes it to absorb energy and swell. So eventually this will clear out a lot of the low Earth orbit junk, which is most of the junk. Periodically, we even have to lift the International Space Station, which is about 250 miles up. It's just at the upper end of LEO.
Meaning low Earth orbit, not
low Earth orbit. Yeah, not the constellation.
How are they going to lift the space station with the rockets visiting?
It has rockets on board it.
Oh, okay.
They use the capsules that are docked.
Yeah, that too.
Yeah.
How about the Hubble? The scope?
Hubble is much higher.
Is it?
Yeah, Hubble's at least twice as high.
Yeah.
I was going to point out to Ron the scale set over on the right there. Okay, so what they have a measurement of is the total amount of wattage per square meter there, and you see it's in milliwatts per square meter. And if you think of the visible, Rhonda, the solar constant, if I'm right, Jerry, correct me, is in the ballpark of 1,300 watts per square meter. Yeah, okay. So that's really teeny weeny. That's very small.
Well, is ultraviolet between violet and the color spectrum and your gamma and X-rays on the upper end?
Yes.
Yeah. My guess, Ron, is that the wavelengths of these photons is in the ballpark of what we studied. I'm just guessing. Which
they have the nanometers up there.
Okay, I was going to say we studied at 171 angstrom units, which would be about 17 nanometers.
Would be down off.
Where are the angstroms at?
So that's the yellowish graph part.
I got you. Okay.
So Are all these graphs, gentlemen, including this one, pretty much on that 22-year scale of sunspots?
Yeah,
Oh, sure. Mm-hmm.
yeah,
Yeah, it
Is
looks right
milliwatt
into that.
a milliwatt is a thousandth of a watt?
yeah.
Yes.
Oh,
Mhm.
100th of a watt.
100.
Oh,
This would
1,000.
be
One thousandth.
microwatt.
Is that
Oh.
micro?
Or Milla.
Milli is
Micro would have
100
been the
and
little
micro is
mu, I think.
1,000.
Yeah, I would guess that's milli.
Well, what is it in the atmosphere that takes this on? Is it the ozone layer?
I don't know the chemical. It's in the paper, but I didn't make a chart of it.
Mm-hmm.
The this is the first flare that they studied, or active time period, second, third, and now start of the fourth, just as the previous graph.
Mm-hmm.
But
Gary,
remember,
does it seems to be declining, and what does that indicate?
No, it comes and goes.
Yeah.
Okay,
This one is
fine.
going high again, or high-ish.
okay.
Yeah, here it's back up. And we're getting a lot of activity from the sun the last few months.
Had a good one yesterday.
Yeah, it's really nice.
Okay, let's see if I can get back to the other system without losing my feed.
Bye, Gary. uh, maybe if I say goodbye now, you won't go. Yeah,
Wow.
look at you're
Ooh.
back.
Black holes.
Oh, M80, huh?
Yeah. Now this, come on.
Did you say this was Messier 80,
Yeah, it's M80, Ron.
which is a
Globular.
star cluster,
Yeah, a globular cluster. Uh-huh.
globular? And
So
it's
there
got a
are
black
probably, tens or hundreds of thousands of stars in this cluster.
plus a black hole that we've
I
seen
guess there's a
inside.
black hole in there too. Yeah.
Whoa.
This is a good indicator, Ronnie. Most of the time, when you see globular clusters, the stars get more and more dense towards the center.
Yeah.
So it's like a big snowball in out beyond our galactic plane.
But
Mhm.
not all star clusters do that.
No.
No. These star clusters were very early,
Right.
before our galaxy collapsed into a disk. And these did not collapse with the body of stars that collapsed.
Mhm.
A rotating sphere of objects, as they interact, they will average out to a common angular momentum through collisions or close contact or close flybys. The globular clusters that formed at that time did not experience the same forces to get it to collapse into a
Black hole.
so it stayed a ball around what later became the plane of our galaxy.
Mhm.
Well, it's sort of a mini galaxy inside a bigger galaxy.
It is a mini primitive galaxy. It's a
Very primitive,
combination of stars.
And probably they might have become galaxies, but the larger, the more massive stars were stripped by our Milky Way.
Yeah.
But
Well, we
that's
sucked away the
happening.
gas.
That is happening with the tidal forces, because these things, some of the ones that are closest to us and that pass through our disk, they actually have strong periods of interaction. But the point of it for this topic is that there are more chances of star collisions. And the thesis is that black holes grow by star collisions and by black hole collisions. And these are more likely to happen in globular clusters than in random parts of the galaxy.
And Chuck, is this in Scorpius? Am I right?
Which one is it?
M80?
80?
Yeah, that sounds right.
Yeah, I think it's in Scorpius. Yeah.
I get that question a lot, Jerry, out in the star parties, in the globular clusters. They always ask me if they get more and more dense to the center, is there a lot of collisions? And I
Yes.
usually say no.
Yeah, there are.
Well,
Mhm.
but you don't have to actually smash together. The stars are close and just passing by, they act like a collision a little bit.
Okay.
in order to do a black hole, you have to actually have them smash into each other.
Okay, I'll have to change my my
Yeah,
ways.
that's why you get what are called blue stragglers in them.
Yeah.
Mhm.
Okay, that's what
But
they are.
you could tie all of that you're talking about to the LIGO thing we're going to talk about later, couldn't you?
Yeah, they
Gravitation-
use some of that data here to look at the spins and that's how they decided there were these two populations. The lower mass ones formed from the stars exploding, and the higher mass ones formed from mergers.
Oh, here we are, gravitational waves.
Now, this is what happens when two black holes find each other. Down here, they're just having coffee. Then they start going out together. And then they decide they like it.
Yeah.
And so as it does it, these two things, because they're centers of waves and they rotate around each other, they will, if you had like a mass meter, it would point at one, and then as the other one was closer, it would point to that. And so that gives us a wave motion.
Yep.
And so that's the wave that you would see. These LIGO detectors that we have, for example, would see these situations as they got closer and closer and closer. And then as they merge, they do this thing here. And this is called a chirp wave.
Mhm.
So, and they're come down to a single body and then it relaxes down. So there are two waves here. There's what's called an overtone and a fundamental tone. The fundamental tone is continuing on, but we will get to, this is another picture of the same thing. This is the area law, which, who was the guy in the wheelchair?
Hawking.
Stephen Hawking said that when two black holes collide, the area of each black hole sums to give the surface area of the resulting black hole. So
But it's bigger.
yeah, it's bigger. It's
Yeah.
conservation of area. But that's the event horizon. And when something falls into the event horizon, as you know, from our point of view out here, as it falls in, its time slows down and actually stops. And we would see the object if it wasn't interfering with the accretion disk, we would see the object just stop at the event horizon, and then slowly, very slowly over a long time, it would redshift and redshift until we couldn't see it anymore. But the information, the object, the image of the information of the thing is always there. It never goes in. Everything that goes gets to the event horizon stays on the event horizon.
Why larger?
So
What?
all
Why
the
is it?
stars that ever sucked in is still there
Yep.
for us to see.
Torn apart, but they're all there in a thin layer.
Why does it get larger?
Why does it what?
Why does the merging become a larger area than the?
Well, that makes sense.
Because-
Any two things that get together become twice as large.
Yes, but it's even greater than the sum.
The idea is that the conservation of information, that the information contained on the first two objects that collide or combine has to stay on the combined event horizon, and it needs that area to preserve that information. And this is where the idea in physics that information cannot be destroyed in our universe. It can only be changed in form.
Huh? How interesting.
Yeah. So, and this is two of the wave, what is it? The gravitational wave detectors in Hanford, Washington, and in Livingston, Louisiana. And this is the spectrum that they get, which is the chirp waveform.
Wow.
This is the actual waveform. This is what you hear on the thing. And they have a recording, but it's too hard for me to get it going on here. But it just does that. It just makes a chirp. You know, you hear the rumble.
Yeah. Jerry, do you see where it kind of peaks there? 256. That's middle C on a piano.
Oh, is it?
Yeah, that's
You're
middle C.
kidding.
No. If you tune your
Oh,
piano,
that's-
Tim,
that's it.
256.
256, I see, huh?
The octave is 512.
So
Uh-huh.
there is music in the universe.
No, now let's not go there.
Additional
This is 10 years of detection, 2015 to 2025 or 2024, it says, of compact binary collisions with black holes and neutron stars. And each one of these is a chirp spectrum. Some of them are very prominent, some of them aren't. But this just shows you the sheer number of these things that they have detected over this 10-year period.
Wow.
Yeah. Did you see the scale, Jerry, on your previous graph? You see the Y scale? Look at that. 10 to the minus 21.
Where do you have 10 to the minus 21?
It's up on the left there on the upper data set.
Brain, the far left. Yeah.
Oh,
Isn't that wild?
no, I didn't look at that. Yeah.
Yeah. Eensy weensy.
Uh-huh.
And the top one is what they measure. The middle one is what they would calculate theoretically. So you can
Okay.
see the match.
Pretty
So,
good match.
In solid state physics, crystals, you've heard the phrase stress and strain. Well, stress is the force and strain is the distortion that results from the stress. So this is distortion of the object.
Of space-time, yeah.
Yeah, and that's very small.
Yeah.
But do I understand, gentlemen, that they sometimes, if not usually, know where these things came from somehow?
Now that we've got multiple detectors, yes, you can do a
You can triangulate, huh?
Yeah, we've got chart coming up on that.
Okay.
Oh, okay. I'm jumped the gun. All right.
Now this is two of our
the
and
two
in introduction
LIGOs.
to their weird chart, two of their detectors. LIGO, Virgo, actually there are three of them, but only two are LIGO, Virgo, and Kagra, which is
Well, LIGO is two in the US. Virgo is one in Italy, and Kagra is one in Japan. So now we've got four.
Wow.
Now this is a weird chart. The horizontal scale means zip, zero, nothing. It's just things are just spread along that to keep them separate from other things. The graph shows, for example, here that this object combined with this object to become this object. And these are the number of events roughly in time, but the time scale is not recorded here.
Yeah.
You'll see some very creative versions of this chart. I guess someone was bored.
Yeah.
But
it's amazing, Jerry, the baseline, just about the diameter of the Earth, right, for these detectors.
yes.
Can pinpoint these creatures. Pretty cool.
So this is in solar masses. This is 80 solar masses. This is 1 solar mass. And this is known neutron stars down here, that mass. And here is X-ray binary black holes and LIGO Virgo black holes up here that have grown from these collisions. So we know they grow from collisions, but we don't know if they only grow from collisions. Now this one is arranged artistically. Again, the horizontal axis has no particular meaning.
Looks like a bird in flight, huh?
Yes.
The
And yeah, so this is all three of them again. Now with three things, based on the Earth the way they are, we can sort of get an indication of direction. And they call it masses in the stellar graveyard. That means the product of collisions. So here's the product of the collisions. This is a 200 some plus solar masses. That's a big one.
Yeah.
Combined.
Yeah.
So, anyway, pretty chart.
Yeah.
Now this is the best we can do on localization. This is the LIGO localization. Knows it's somewhere along there. And this is the LIGO and Virgo localization. So it pins it down to here.
And now with Kagra too, you can get even smaller.
Yes, you can. And I happened upon that chart. It was a nice chart and I couldn't find it again. So
Why is it shaped like a fat Earth? I don't understand that.
Well, that's the distortion by the way they map it.
Right.
Yeah, the detector is two linear arms at right angles to each other.
Right.
And that will give you a certain, like, if it's lined up right, it'll give you just the azimuth of it.
Yeah. And Ron, you can see over on the far right, the kind of the heart of our Milky Way.
Yes,
All the clouds. And then on the very bottom, Jerry, you can see the Magellanics.
yes.
Yeah, that's pretty cool.
So you can
So
see
that
how
makes,
distorted the view of the sky is.
Yeah, that's right.
And
Now,
that's
this
why
is,
these ellipses are distorted.
Yes.
yeah, this stuff is from the gravitational wave detectors. This stuff is from photographs of our galaxy.
Yes. Mm-hmm.
oh, the difference between the blue crescent and the lighter blob in the middle is what? What are the two?
This is if you take the data and try and figure out where it is looking from just LIGO localization. Here is if you combine LIGO and Virgo localizations, you can get your accuracy down to
pinpointed.
this.
Yeah, more pinpointed.
You can narrow it
Oh.
down.
Yes. Mm-hmm.
So that all this data is coming from if we're at this CAGRA, this is going to be a smaller area yet, but all the
Yeah.
data they're receiving
Yeah.
is from this
And the
one spot.
localization is not this shape. The localization is this little circle.
Yeah.
Oh,
So
Yeah, the circle is kind of their best guess for what it is. And you can see the blue one is if you only use the LIGO data,
yeah,
that little tiny circle there, that's where you'd start to go looking. But you'd have to search this whole blue area.
But
And
this
now
is,
with the green area, now you've really zeroed in on where it happened.
but this is it. What I'm trying to get at is where the localization is the data that these graphs are displaying.
No,
Would
this is one detection.
Okay, okay.
well, just
yeah,
one.
yeah.
This represents one collision.
Yes.
It's no LGMs or anything.
Right.
Okay, we're back to Psyche now.
Okay,
On our way to,
enough for black holes. We'll probably
Yep.
see more about that later.
okay,
Psyche is a multi-year trip to this asteroid that it is likely the metallic core of a planet from that had its outer layers stripped off by a collision. The probe is going to arrive in August of 2029. It's 2.7 AU out. This is the Earth here where it was launched in 2023. And right now it's passing by this red line.
Mm-hmm.
Let's see, it's going by Mars right now.
Yeah. So that point out there, Jerry, is between Mars and Jupiter, I think. Does that sound right?
What point?
Oh, the approach where he has approach up.
Yeah.
Yeah.
Yeah. Mm-hmm.
Yeah, it's not going to land on there. It's going to orbit,
Mm-hmm.
as I understand.
Wow.
Right now it's going by there, and it took a really horrible picture. Cruise trajectory is black, so that's what I'm, okay, so this is going out here. This is the thing that's going by Mars. And then it goes around here, and then it goes out there, yeah.
Okay.
So, when it's going out in these regions, it gets a look at, I think, at as it's approaching the asteroid. So this is a
Wow.
graphic. It's not an actual picture of the probe, but right now the probe is 2,500 miles approximately from the surface of Mars.
Wow.
This is going by, I think, earlier this week.
I think it's today, isn't it? Or I'm maybe mixing it up with this whole Venus and Moon thing. Never mind.
No, could be today.
but it's getting gravitational assist, right? That's the reason it went by Mars?
Yes.
Yeah.
It'll take images of Mars, Chuck,
Yeah, they're
pulling them in
telegraphy
now.
cameras.
Nice.
Yeah.
Wow. That's close.
Yeah.
So this is a picture taken of Mars. This is the backside of Mars. And this is the front side that's overexposed.
Hmm.
And the actual raw picture, you can actually see the squares that are the pixels. It's been processed to smooth it out.
But the sun would be above this picture and out of sight from us, wouldn't it?
Yes.
Yeah, this is from the space probe.
I know, but you can tell where the sun would be.
Yep.
Yeah. So if you're here, well, if you're down here, you'd see this part up here as a crescent.
Yeah,
And
yeah.
so this was taken before today. Obviously, I have it in here. So it was more looking at the backside down here in the shadow side.
Is that white splotch on Mars? Is that a polar region?
Yes, that's a polar cap.
The last picture?
Okay.
Yes,
Okay.
the artist's rendition. And the flyby was the 15th. You're right. It was last week.
Okay. This is about a little known constellation called Crater, which apparently means the cup.
Yeah. Yes,
And
it means.
this chart is one of the few that I found that makes this, puts together a crater, a cup-shaped stick figure with delta shown here, delta crater. And this is,
I think this is also related to the story of the crow in the water in the cup, Chuck.
Yes.
Yeah. So
what's that story?
the cup was running out of water, so the crow, because he's so smart, would put pebbles in there.
Oh,
Okay, it would raise the water level. So the cup and the crow are next to one another in the night sky.
That's not a
Okay.
myth. That's
And
fact.
another version of that myth is Apollo said, "Hey, we need some water," and the crow said, "I'll go get it."
Yeah.
And the crow went off and kind of diddle-daddled around and ate some grapes and everything, and then finally came back and said, "Oh, I wasn't able to get any water." And Apollo knew he was, lying to him, so he popped him up into the sky next to the cup full of water, and the crow would never be able to drink from it. So the crow's always thirsty.
Yeah, that's really neat. Yeah.
But Neil deGrasse Tyson has shown shots of that actual crow doing something like that.
Yeah. Could have been worse, Ron.
But
Apollo
Sure.
could have eaten crow.
there are several old myths that had the crow had to show up in, so I guess he was multitasking.
yeah, but crow pie is really delicious. I have a lot of it.
Now,
It goes
in
up
an
at
earlier
odd
bit
times.
of the text, it said the Delta Craterus didn't have a name, yet here it's labeled with a name. So apparently that's not an official name yet.
That was yeah, I found that Astronomy Magazine says the only name star that has a name here is Alkys.
Hmm.
But I found this chart in another site that has Labrum and Al-Shirasif.
Hmm.
So I don't know what to make of it, but each of these astronomy magazines, the amateur astronomy magazines, they have different things that they recognize and don't recognize in controversial area. For example, Astronomy Magazine does not recognize 110 Messier entries. So
Really?
they do 109.
Mhm.
But anyway,
What's the picture that would go over this on the inside of the planetarium?
A cup.
A
yeah,
cup?
Yeah.
I don't
Like a
recall.
goblet with the stem and then the cup on top.
I just recall animals, crabs
Nope.
and rams and
No,
bears.
no. There's Ariadne's crown and there's Berenice's hair and there's a sextant and there's a microscope and there's a clock.
Yeah.
That's a cup, huh? Not a handle on it, but it's on a stand, I guess.
Yeah, like a goblet.
Oh, okay, got it.
Yeah. Yeah. Zodiac is, animal path.
Yeah, so the zodiac ones, except for Libra the scales, are all people or animals.
Animals, right?
And then
Well,
the
who named
Romans
it?
added Libra in later, so they stole the scorpion's claws.
Mhm.
Who gave it the name Crater, I wonder?
Well, it's a
Cup.
Greek story.
Yeah.
Yeah.
Greek.
Greek.
Cup
Is
becomes
this
a crater.
Latin? This is Latin for cup, but
Yeah.
I guess you could look at a crater as a cup in a way. Yes.
Third declension. Crater craterus.
That
Wow, what a-
labrum, I looked up and I was thinking it's a bone, but it's cartilage, like in a shoulder.
What is?
Labrum, the name
Oh,
labrum.
labrum.
Oh,
So maybe when you look at that constellation, it does actually look like an arm coming out, and maybe they named it for a shoulder.
Wow. Wow.
well, what the heck is this? What's that bright thing behind the moon?
that's that galaxy that we just found.
yes. They just
That's
discovered it's a dwarf galaxy that orbits ours along
Wow.
the Magellanic Cloud, but it's really hard to see it. So don't go out and try and show it at a Saturday star party. This is a picture of that dwarf galaxy magnified in brightness by 1,000 times.
Wow.
Oh,
And there's an image of the moon superimposed on it for scale. So this is 30 arc minutes across.
Mhm.
And so it's not far away. It's a fairly big thing in the sky, but our chances of seeing it, even by photographing, is remote. But
Huh.
it's called Crater 2. So it's one of the dwarf galaxies around us.
Wow.
Crater 2,
Crater 2.
and it's about a degree across.
Half a degree.
About
Yeah.
half. Yeah, like the moon, Ron. Half
Yeah.
a degree.
Oh, okay. Well, I could give
And
it
the sun's a half a degree.
Yeah.
Wow.
So this shows a map of the sky with our
Local
Milky
group
Way
around
here,
it.
and there are various dwarf galaxies around here. Now, it looks like I grabbed one that doesn't have Crater 2 on it.
Mhm.
So anyway,
It's
It would
southern
be off
hemisphere
toward
though, right?
Leo. It'd be off toward Leo and Sextant, so it would be somewhere in the upper left.
yeah.
Mm.
Oh, this
Southern,
is
it's southern hemisphere, Jerry?
30. This is,
Oh.
it is in the southern hemisphere.
Yeah, and
Oh.
Leotam, the
Well,
pump.
It's below the horizon, maybe from below the projection of the equator from our point of view. So that makes it southern hemisphere.
Mhm.
Okay.
Huh. Yep, we got
Mhm.
a picture of it a while ago.
Okay. No, they don't give an NGC number for it. Sorry.
And
Yeah, because it's
Andromeda,
newly discovered.
Yeah.
Andromeda to the lower right has its own little local group around it, right?
Andromeda has its own set of things.
But it's part of our local group, so.
But it's the one that's coming at us. Everything's coming at us, isn't it?
No,
Not all of them? Am
no.
I going to absorb all those little galaxies?
Now, there's lots of faint galaxies in Crater. None of them are Messier objects. But for example, this one is very nice, NGC 3511. And this is taken by the Hubble Space Telescope. It was the picture of the week a short while ago. You can read the caption there in the reading in the talking points. Okay. And then we have two of them close together. And these are right down here. You see this NGC 3511?
Mm-hmm.
That's one of them. And the other one is almost on top of it at that scale. And this is 3511 and 3513.
Okay.
So these are two right at the bottom of Crater. Barred spiral face on and what looks like a barred spiral at a more oblique angle.
Mhm.
Huh.
And then this is 3981, also in the region.
Wow.
Just got a lot of outliers. It's been distorted by probably these objects around. Well, these are probably stars in our galaxy, but it's distorted by something off here to the side that's pulled one of its arms out.
You can see probably an asteroid in there too. If you go in the upper arm at about the 12:30, 1 o'clock position, yeah.
Yeah,
Yeah, the color.
yeah. And they obviously used red, blue, and green, I think, red, green, and blue filters to get this color image.
Yeah.
So they had a rotating filter wheel. And then there's a little red thing up there which looks like it was something that was there only when the red filter was on.
Mhm.
Can I throw in my stupid question of the week, gentlemen?
Okay, go ahead, shoot.
My understanding about the way galaxies are scattered around the universe is filaments and nodes. And we've seen, the patterns.
Yeah.
Would us and our local group, along with the Andromeda, be a node or part of a filament? Obviously, we're a collection of,
Our entire cluster of galaxies, the Virgo supercluster, is a node on that picture you're describing.
well, the great attractor is sort of like the center of if there is such a place.
There is no real center so far that we know about.
The great attractor would be another bigger node.
Okay, do they know which constellation it's in?
Well, it's
We know
blocked
where
by
it is roughly.
yeah, it's blocked by our Milky Way, so I don't have
Oh, it
any
is?
images of it or anything, but
The fat lady's in the way.
yeah.
So we're in a node, an area, a collection, or what's the word I'm
Yeah.
looking for? A point
Kind
where
of,
they
yeah.
join.
Probably on the outskirts of a node.
That means there's voids in between these filaments, or
Yes.
there aren't
Yes.
many galaxies. The letter G.
This is the quasar that is in the constellation of Crater.
Ooh.
And this is a galaxy, and it is lensing. This is a lensed image of the quasar. So is this, and so is this, and so is this. So this galaxy is showing us 4 images of the quasar located behind this galaxy.
And what's a quasar defined as?
It's an actively feeding black hole.
So it's all from its accretion disk.
Yes.
Or the jets coming out of it, more likely.
Yeah.
Okay, and that spans what, many light years across?
Good question. I think it would be several light years across.
It'd have to be
It
that
could be.
bright, I guess. Wow.
Yeah.
RXJ1131. It got a phone number, not a name.
Yep.
Well, those are probably the celestial coordinates for it. 11 hours, 31 minutes, and 12 degrees, 31 seconds.
There's no way you gentlemen could focus on this.
It's probably a little dim, yeah.
Wow. Who just got up? Tim Crawford? He's going to miss our big close. Just coming up.
So this picture of the quasar, of the Einstein ring of the quasar, is a combination of 2 images gravitationally lensed into 4 copies by a galaxy, which we just discussed. This picture was taken by the Max Planck Institute, or assembled by the Max Planck Institute for Astrophysics, the Technical University of Munich, and Academia Sinica Institute of Astronomy and Astrophysics, and the K.C. Wong University at Tokyo's Kavli Institute for Physics and the Mathematics of the Universe. So this was not a single camera frame that was done with an amateur scope.
And your text mentions that this is the first black hole that had its spin directly measured.
Yes.
This looks remarkably like those artist conceptions of black holes, where it has everything around ethereal, mirror-like, circular, with everything
Well,
swimming in the middle.
this is not an accretion disk.
Right.
It's not.
This is a galaxy that's close to us, and it's lensing the quasar and any disk it may have into this object.
Yeah, it's smeared out all around it.
Yeah.
Huh.
Its galaxy is probably those other bluish filaments.
So if we look closely, we can see Matthew McConaughey on a water planet.
On
You can see him
gigantic
4 times.
Chuck, when you say they measured the spin, you're not talking about, left or right. You're talking about at an atomic level?
a rotation.
A rotation of the black hole.
Oh, okay.
How fast it's spinning.
Spin, yeah.
So this is a quasar.
Yes.
But not all black holes, even the massive ones at the center of galaxies, become quasars. Become
Right.
bright beacons, do they?
Right. Although they probably go through that phase at some point when they're growing, but
Yeah.
But 50, 60 years ago, I remember people were wondering, scientists were saying, what the hell are they? And they
Yep.
were distant. They were really powerful,
They
but
look
they're
like
not gonna,
stars and they were strong radio sources, so it means quasi-stellar radio objects.
okay, but they're all far away. There's not many around us, or we
This
might
one
be in
is
danger.
this one's 6 billion light years away.
Okay,
Whoa.
that's what I said. Why don't they have them in this area, in our neighborhood?
Because they're sort of an artifact of the earlier universe when stuff was happening, when things were closer together and there was more gas. And now
So,
they've
no,
kind of quieted down.
so we may be seeing the residual light from then, and they may have flamed out by now. They're not even in
Yes.
existence.
Yeah.
Well, the black hole's still there, but they're not active like that anymore.
And they don't line up anymore to do the lensing.
Yeah.
Yeah.
And Ron, if this is 6 billion light years away, it took 6
Well,
billion years to see this, right?
Yeah.
That's before
right.
our sun was made.
Yeah.
So this
So,
predates our sun. This
well, maybe
this light.
we were part of a blazing quasar, thousands of,
Our galaxy could have gone through a quasar phase, yes.
Yeah.
I'll be damned.
Yeah. And there is a
Like,
quasar you can see with a modest telescope. It's about 3 billion light years out. I don't know, Chuck, have you ever shown that to the public?
2.4 billion light years. Yeah. 3C273.
That's it. That's it.
Yeah. I had to use a camera to show it, but
Okay, I was going to say, yeah, okay.
and
Well,
that's in Virgo, I think.
That sounds right.
Yeah. There's
and
another one that I managed to image with my 5-inch that's 12.4 billion light years. But that took a longer exposure.
Wow.
And it's just a dot, of course.
Yeah.
Have you seen any of the little red dots?
No.
you'd think its light would have turned to infrared by now, and that's all you'd see is reddish.
That's
Yeah.
right. At
Well,
some point that happens.
It's only 6 billion light years away. I mean, and
Yeah, mere 6 million.
yeah, and it's high, it's really high frequency. I mean, it's it's giving a lot of UV and X-ray and stuff. So that stuff is being redshifted into the bright
Yeah.
visual band.
Yeah. And when you take it, Ron, when you take this in context of, time of light travel, it just puts a whole different perspective, on objects like this,
Yeah. You'd think they'd have computer programs, maybe they do, that can estimate where they are and what they are today. Not even that in that location, probably moved.
Yeah.
Jeez.
Amazing
And
stuff.
what does the web show? I mean, that web is all tuned to infrared, and that's 6 billion
This-
years is right up its alley. And
This might not be,
And the target list?
yeah, I mean, this might be kind of a little bit bright for them. I don't know.
Interesting. Yeah.
oh, really? They don't want to point it at something too bright. It floods those 18 mirrors or whatever they're
Yeah.
hexagon gold.
Yeah. Wow.
Well, they leave brighter objects for other scopes to look at that you don't need the power of the James Webb.
Yeah, 6 billion light years, obviously other things have imaged that, like Hubble and Chandra.
But 6 billion is only half the distance between those 5 strange ones that it saw that it locked in on first 300 million years.
Uh-oh.
Or so.
Uh-oh, Chuck, you're the host.
Uh-oh.
Uh-oh.
We lost our president.
Yeah.
He must
Well,
have
that means-
switched from that display that's not burned out to the other one. And
Yeah.
Jerry, we love
Chuck?
you anyway.
While he still got you guys, Chuck, has Jerry ever talked about that 300-mile wide in our solar system? It's a planet in our solar system that's way out near Pluto. Has he talked about that?
one of
So,
the
there was a write-up in the New York Times just the other day about it.
oh, the one with the atmosphere.
Atmosphere, yeah, that
Yeah.
one's interesting. It shouldn't have an atmosphere, right?
Yeah, we covered that, I think.
You did,
last
okay.
week,
I was
week
just
before,
curious. Okay.
because it was an occultation find.
Does it have
Yes,
a name?
that's right. That's right.
What's the name of it?
Oh, it has a name, but it's your typical phone number name.
But
I might have missed that Monday, Chuck.
Yeah.
I just wondered.
I've never heard that.
I think it was
Oh,
last
boy.
week or the week before. And
Yeah,
it's a
we
dwarf,
did
right?
talk about that one. It was the University of Tokyo.
That's right. It is a bunch of Japanese sites.
I
Yeah.
like that, Chuck. A phone number name.
Well, that's Ronnie's. That's Ronnie's
That's Ron's,
phrase.
yeah.
Well, gentlemen, we're
Uh,
gonna have to sign off without him. We'll use our little X in the upper right part of the screen and see you all back here on your Zoom screen next Monday morning for number 274 into our 6th year of the Astro Hour. Thank you. You made my day.
right.
Yep. Good show,
Again.
Jerry.
And
Thanks,
Tim,
everybody.
let me know if you want to see 26.
That's
I
right.
will.
Happy. How do we say goodbye in this language?
Hasta Nebula.
Hey, hasta nebula, everybody.
Bye, everybody.
See
Do
you.
widzenia.